भारतीय विज्ञान संचार समूह में आज बहुत बहुत स्वागत है। काम से कर गए कुछ जरूरी काम आया होगा, 2 मिनट में वो आते हैं और तब हमको सुन पाते हैं।
ओके मैम।
बहुत बहुत स्वागत है सर आपका।
ओके, थैंक यू
आप
मैम।
लाइव है?
हाँ, लाइव में है, प्रॉब्लम नहीं है।
ओके सर,
रेडी
जी, यू कैन स्टार्ट सर।
ओके मैम। फ्रंटे করবে
शुरू कर। দেরি হচ্ছে।
Dear students, and today is 30 July 2024. I am Krishnendu De, Assistant Teacher of Kanchannagar D.N. Das High School. It is in Purbo Bardhaman, Bardhaman town in West Bengal, Bharat. And today's topic is practical analysis of LCR circuit. And it is a curriculum based topic, and that is learned by our 10+2 students of our state and also throughout our country, Bharat. And today I discuss LCR circuit not in theoretically, but I will discuss in different way, and that is TLM method. And it will be very joyful teaching and also fun activity, activity based learning, and also compatible with National Curriculum Framework, that is NCF, and also National Education Policy 2020 tells us that if you teach your students by activity based or by activity based learning, then students will understand far better way than first. And before studying, I must convey my pranam regards to our lifelong devotee of science, the priest of science, Anil Kumar Tripathi ji, and his whole team, and also his local counterpart, Sachdeva ma'am, Gita Sachdeva ma'am, for their devotion towards science and also their love and affection to our Bharatiya students. Today I am going to my topic, that is LCR circuit. And why the name is LCR circuit? Because in LCR circuit we use resistance, capacitance and inductance. And we all know Ohm's law. So we already familiar with resistance I don't know go to the term resistance and such that just I am giving some introduction of LCR circuit. LCR circuit is composed of resistance, capacitance and inductance. Just that is inductance, and here capacitance, and it is resistance. So across voltage VR, VC and VL. So in a resistance, when passing current through this wire resistance and voltage drops across the resistance and current passing through the resistance, so we get a resistance effect in the circuit. And a capacitance is basically two plate without connecting anywhere to different plates, keeping some distance, and in between two plates air or any dielectric medium may exist, and one plate is giving any charge, positive charge, and another plate is grounded. So when current passing through the capacitor, so capacitor itself block DC but pass AC current, and in a capacitor current always leads resistor voltage. Current always leads voltage, that is current and voltage leads between the phase angle 90 degree, and when current passes through the resistor, so charge accumulation in the plate occurs, and after charge accumulation it induced voltage, and by passing current, and it results into reactance, and that we call reactance of capacitance. And after the term resistance, capacitance, I am now coming to inductance. Inductance is basically a wire winding or rounding over a iron core, and in inductor, that is inductor coil, we familiarly known as inductor coil, and in inductor, when current passing through the inductor, current lags voltage, and the phase angle between current and voltage, that is 90 degree. So if an AC current passes through the inductor coil, then the current changing with time at induced, and that is induced voltage throughout in between the inductor, in two sides of inductor, and that results induced voltage. So the term comes the inductor capacitance. So we get inductor capacitance and inductor reactance. So capacitor reactance and inductor reactance. And in capacitor we get current leads voltage, but inductor current lags voltage. And in capacitor, charge is accumulating and we get electrical energy stored in capacitor, but in contrary to inductor, magnetic energy is stored between in inductor. So both electrical energy and mechanical electrical and magnetic energy stored in capacitor and inductor. And when the relative effect of capacitance reactance and inductor reactance, and we get as a impedance. So the total capacitor and inductor we get impedance, and another we get resistance effect. So we get resistive effect and impedance effect. Impedance effect of capacitance and inductance. And when inductance reactance and capacitance reactance are both equal and opposite, and that time we get only resistive circuit. And at that point, when we arise that point, we call it resonant circuit. So these are the some basic primary parts that I discussed. Now the main point, today's attraction, and I made an TLM of LCR circuit. We just saw before you the LCR circuit. What do we make? This is a box. After opening this box, what I get? This is wire. This is wire, and here you see a transformer, and here you see resistance, here you see capacitor, and here you see inductor coil. So I'm just plugging the plug, and you see a bulb is glowing. You see a bulb is glowing. Okay, a bulb is glowing. Can I put up the switch? Okay, I'm just. So, you see, a bulb is glowing. If we increase the resistance, here it is resistance. If we increase the resistance, then what will happen? So, if we increase the resistance, then resistance is increasing, so current flow is decreasing, and that results bulb is totally off. So it is, we all know that is resistance effect. But here you see resistance effect and also capacitor effect. And here you see a switch. If I if I off the switch, that is bypassing, then you see that glows more. If I bypass both resistance and capacitance, then you see what will happen. This is bypassing capacitor and this is bypassing resistance, and I put off resistance part, then it is diminished. If I leave capacitor part, then it is diminished. So glows less. Again you see resistance part, what effect? If I bypass the resistance, so the bulb glows more. If I bypass the capacitor, so it is glowing more than before. Now I will show the inductor part. So what is the inductor part? Now here you see a coil, and it is a simple rod. When I push the rod in the coil, what will happen? You see, what will happen? Then I am putting off the switch. So when I push the rod, yes, you understand? This is the effect of inductor and inductive reactance. Here comes play in the circuit. So it is a one type of resistance called impedance. So impedance effect is here, and that results lower down the current flow. So bulb is glowing less than before. Okay, understand? So I am just returning to main point. So here the part inductor, here the part capacitor, here the part resistor. So the total TLM composed of resistance, capacitance and inductance. And if we make them understand by this way, by simple doing this TLM, then our class 10 plus 2 students will understand more theoretically and practically, and they will love physics more and more. And also it's my proud moment that I made this TLM after 3 months trying. After trying 3 months, then I complete this TLM. And also I am giving a message to the viewers. If you want this TLM to your students, to your beloved school students, then I can sell this TLM with nominal cost, also material cost, and with also labor cost. And if any respected teacher of school or any person interested to purchase this item, I can happily hand over with nominal cost. I think it will be helpful and joyful teaching to you. And next day I will come up again with another TLM. I have to leave now. Okay, thank you for giving your blessings and patience and your time consideration. And I thank you all visitors, well wishers. Thank you.